going to tell you about our project that we did for embedded systems at Virginia Tech. Our project this semester was to create a wireless remote that would record and play back gestures and to turn on and off lights. The remote will capture sensor data and then send it through a wireless transceiver over to the Spartan board.
The Spartan board handles all the gesture processing. We'll take data from this PIC here that acts as a receiver to the remote and figure out and record gestures. And then if a gesture is recognized, it will send it back through ECE4534 to the Insteon PIC over there.
So we are using the Insteon to turn on and off the lamps. After it receives gesture from the Spartan board, it will convert into Insteon command into this PIC over here, and it will transfer into the Insteon modem, and then its lamp link device, it will turn on and turn off the lamps accordingly after it receives gestures from the Spartan board.
Okay, we're going to demo our system for you right now. Just a little bit about how the remote works. There is a device button and a program button. So right now our system is set up to control two devices. So you can toggle which device you want to use with this button, and then when you press the program button, you'll have about a second to record a gesture. So right now I'm going to go ahead and record a gesture for each device and then play them back. So the first device I'm going to program with this gesture, and the second device I'm going to program with this gesture. And so now I should be able to just play them back and the lights should turn on. So this should be device 1, and this will be device 2, device 2, device 2, and then if I do it again, they should turn off. So device 1, device 2. And then, so now we can go back and reprogram each device with a different gesture. So I'll reprogram the first device with a semicircle, and then the other one with the opposite direction. So now, when I play them back, it turns on device 1, and then this should turn on device 2.
For our system, we have to design our own PC board to communicate with the system. This is the remote that I designed. The board is powered by a 9-volt battery over here. The voltage will be then converted into a 3.3 volt using a voltage regulator. This 3.3 voltage output will be serving as the voltage supply line for all components on board. For motion sensors, we are using right now a gyroscope and an accelerometer to collect data. We're using a PIC18F2680 as a master to collect all data from these sensors to I2C. The data will be then transferred wirelessly to the Spartan board using a pair of my wire transmitter, which we get from microchips. To enable communication between the user and the system, we have a simple interface of LEDs and buttons. We have a programming button to let the user to start gesture recording sequence, and a device button to select which device is being mapped into during the recording. Each action on this button will also affect the LED counterparts. If you turn on the device, the LED will toggle to show you which device is being used, and then the programming LEDs will blink as you are recording the gestures. For a third LED, which is the feedback LED, this LED will let the user know if he or she has performed the gesture correctly or not.
So I designed the software to go on this remote. Basically, the software runs on the PIC, and what it's doing is it is polling the sensors over I2C. It's set up as an I2C master, and it's polling the sensors. It's grabbing the data off of them, formatting it in a specific way, and then sending it out to the MyWi module through SPI, and then the MyWi module shoots it out wirelessly across over to the receiver. The other things that we have on the remote are the buttons, and the software on the buttons is basically just for the device, it's a counter. The way our system is set up now, it can hold up to 8 different devices, and it can also support multiple remotes. And then the program button just allows you to program your gesture. It takes about a second. So this is our receiver PIC. I also wrote the code that goes on this PIC. Really all it's doing is waiting for the MyWi messages from the master remote, and it is a slave on the I2C bus, so the Spartan, which is the master, is just continuously pulling it and asking for if there's an updated message from MyWi, and if there is, I send it out across I2C, and if not, I just send out zeros, so that way the Spartan knows if there's valid or invalid data.
Our Spartan 3 board, which handles all the gesture processing, what it does is it pulls this receiver PIC 25 times a second for sensor data. Once it obtains sensor data, we have an I2C message system which determines whether we're recording a gesture or we're actually processing gestures. And it does processing at real time. What it does, it takes a statistical analysis of the recorded gesture based on the min, max, and average of 3 samples, 4 samples, and 5 samples for a total of about 25 samples, and then matches that with real-time data that's coming from the remote. Then if it determines that the gesture has been made, it will send data back to the receiver PIC here, which will send feedback to the remote PIC, which will toggle this LED right here. And then once it determines that, or after it sends data to the remote PIC, it will also send data back to the Insteon to let the Insteon know that a gesture's been recorded.
So to talk to our household appliance in this situation is using the lamps. We're using an Insteon network to communicate between our system and the lamps. Right now we have an Insteon daughter board and a sample PIC-V board provided by the school. We're using this, I wrote software using this PIC to communicate to the daughter board and using UART, and this daughter board will convert into the Insteon command. Right now the software using the PIC V5 will get, every time it gets an I2C message from the Spartan board, it will check to see which device is coming from, and it will check the state of the device, and it will either turn on, turn off the device accordingly after the gesture is recognized. In theory, we can expand the system more into one device by connecting one scene. Also, we can change the setting instead of on and off of the system by changing the code in the PIC V5 to, right now we can turn on and off the lamps, and even increase the level of brightness of the lamp or decrease the level of brightness on the lamps right now.
Okay, so our project met our initial project requirements. We have a full system that recognizes gestures. It's expandable to multiple gestures, and you can re-record your gestures to any device. And it's all wirelessly done, and we have feedback to the remote using the Spartan board and the MyWi modules, and we're also interfaced with the Insteon system where we can control different lights and other devices.
So for the limitation on our system, the system doesn't work all the time. One of the reasons we think is because the incorporation between the MyWi transmitter and to the receiver and incorporate into the I2C message sent to the Spartan board. As you can see right here, this LED toggle every time the I2C working, but sometimes it's not right now. This means that the system is broken, crashed. So we're trying to figure out a way to solve it. Another limitation on our system is dealing with the interface with the Insteon network. Right now we have the Insteon data board and a PIC V5 as the interface with the modem for the Insteon. Sometimes it works and sometimes it's not. We think the problem is based on the timing issues between the UART setting out and the converting speed of the data board to the Insteon command.
Alright, so there's a few things that we could do to improve our system. The first thing that we could do is to get better sensors. The sensors that we're using right now are pretty cheap. They don't have very many filters on them, and so they have a lot of noise associated with them. So the data that is coming out is not extremely precise. Another thing that we could do to improve it is to have just better communication in general, be it wireless or through the I2C bus, because as it is right now, sometimes the communication causes a problem and crashes the system. And the final thing that we could have done to improve the system would be to have more data samples from the remote, because right now we're working at about 25 samples per second, And we have seen in small tests that working with 50 samples per second works much better, but we could not run our system at that speed. So those are the things we could do to improve it. What is going on?
The range, if you...
This is nothing.
I mean, if you don't have...